For section 3E, I'm going to go through the first problem, which is a bunch of questions about normal curves. In a bell-shaped data set, that means normal, what measure of center should we use? And that is the mean. What measure of average should we use? That is also the mean. And what measure of spread should we use? And that is standard deviation. Standard deviation is derived from the mean. It's a measure of the typical distance. Each data point is from the mean, and they are linked. So when we use the mean, we use the standard deviation, and we use both of those only with bell-shaped data. Any other data shape, we will not use the mean or standard deviation. In a bell-shaped data set, how many standard deviations from the mean is considered typical? So our bell curve, we might want to review that recording on the empirical. There's our mean in the middle, and going left or right, one standard deviation is those typical values. So it is within one standard deviation. That's our 68% center. In a bell-shaped data set, approximately what percentage is typical? That's 68%. 68% is that middle percentage, that area in the middle here is 68%. In a bell-shaped data set, how many standard deviations from the mean is considered unusual? That would be 2 standard deviations. In a bell-shaped data set, approximately what percentage of the data is unusually high? That's 2.5, and unusually low is also 2.5. So if you have any questions about these 4 answers, I want you to review that recording on the empirical rule and how it's used in this class. That kind of goes over this shape, about that 68% in the middle, which is within one standard deviation. Oops, sorry. That should be x bar minus s and plus s. And then within outside of 2 standard deviations is that unusual stuff. So watch the empirical rule recording, which is a short. Explain how we can use the dot plot to find the unusually high values. So once we have our unusually high values, if we have our dot plot here, then once I have an unusual value, my unusually high limit will be a line, and my unusually low limit will be a line, and these are like fences. So everything to the right of that value on the dot plot is unusually high. And everything to the left of the unusually low limit is unusually low. So to answer these questions, I will say use the boundary as a fence and draw a line. R running out of space here. Look for values to the right to get unusually high values. And it's a similar answer for the low values. All right, so that's number 1 from 3E.